So, the second part of our question asked us to name the triangle that is used as an example of the flag. In order to name the type of triangle it is, you need to know about these different types of triangles. So a triangle can be named based on a description of its angles, or it can be named based on a description of its sides. So let's talk about first triangles that are named based on a description of their angles. Angles is something that we should be very familiar with at this point. I hope that all of you can tell me about an acute angle, a right angle, and an obtuse angle. These three things hopefully are really well cemented in your brain. So it says right here that an acute triangle has three acute angles. An acute triangle has three acute angles. All right? How many angles does a triangle have? Well, it only has three angles, right? Every single triangle has three angles. So an acute triangle has all three of its angles acute. Acute angles on all three corners for an acute triangle. A right angle, or a right triangle, has a single right angle. One of the angles out of the three are right in a right triangle. Let me tell you something. There is 0 ways for a triangle to have more than one right angle, and I can prove it for you. Okay? So let's say this, let me change colors. That color's a little hard to see. Let's say that this is a right angle. May not be perfect because I drew it by hand, but let's say that's a right angle. Now if I connect this, the end of this line section with the end of this line section, we have a triangle, right? And here's that right angle. Well, let's see if we can make a triangle with more than one right angle. So we've still got that one right angle that is right here, but let's make another right angle. All right, so a little curvy, but we'll say that there is a second right angle. Is there any way for me to connect this and have it still be a triangle? No. And I bet you $10 that somebody wants to tell me that you can just do that. Honey, that's not a triangle. Because how many sides can a triangle have? 3. How many sides does this have? 1, 2, 3, 4, 5. Okay, not a triangle. So there is 0 ways that you can connect this into a triangle and have 2 right angles. So, right triangle, a single right angle. Let's talk about obtuse. An obtuse triangle has a single obtuse angle. So, one obtuse angle for our obtuse triangle. Let's see some examples of these. All right, so an acute triangle. An acute triangle, all 3 angles are less than, this is our less than symbol, are less than 90 degrees. Any triangle that's less than 90 degrees is an acute angle, right? So if all 3 angles are less than 90 degrees, then all 3 angles are acute, making it an acute triangle. So if we looked at this angle here, if you measured that, you would see that that is less than 90 degrees, less than 90 degrees, less than 90 degrees. So this is, in fact, an acute triangle. We're not looking at the sides at all. We're just looking at the angles. All right, so let's look at an example of a right triangle. A right triangle has a single right angle. Which one of these 3 angles? So here's one angle, here's one angle, here's one angle. Which one of those is my right angle? Touch it. Which one is the right angle? Hopefully, you said that that right angle is right there. And like we talked about, it is impossible for there to be more than one right angle. So a single right angle, one right angle, is equivalent to 90 degrees because we know that 90 degrees means right angle. This angle here, those are both acute. All right, let's look at our obtuse angle. So here is our obtuse angle. And our obtuse angle has a single obtuse, our obtuse triangle has a single obtuse angle. Which one is the obtuse angle? Look at our obtuse triangle. Which one of those angles is obtuse? Touch it. Hopefully, this is the angle that you just touched. This angle is greater than, this is our greater than symbol. This angle here is greater than 90 degrees, and any angle that is greater than 90 degrees is obtuse. So, we know that an acute triangle has 3 angles that are less than 90 degrees. A right triangle has 1 angle that is equivalent to 90 degrees, and an obtuse triangle has 1 angle that is greater than 90 degrees. All right, so that's how we would describe our angles using our triangles using their angles. All right, let's move these guys out of the way. And let's talk about triangles that are described based on their sides. So when we're talking about the sides of a triangle, how many sides does a triangle have? Hopefully everybody just said 3. All right, so a triangle has 3 sides. So when we're talking about the sides of the triangle, we're talking about if we had a ruler and we measured these sides, the sides of the triangle, we're talking about how many of those are equal. All right, so we're talking about how many of them would have the same measurement. So we have 3 different triangles that we can describe based on their sides. Equilateral triangle has 3 equal sides. Hopefully that one's not too hard for you to remember, because if we're talking about all the sides being equal, and equal is in the name of the triangle, hopefully you'll be able to connect those two. So an equilateral triangle has 3 equal sides. Triangles only have 3 sides, so that means that all 3 sides of the triangle are equal. All right, an isosceles triangle. Now, the name of this triangle and the next one are going to be probably pretty new words to you, so it might take you a minute to memorize them. But an isosceles triangle has 2 equal sides. So if you were to measure all 3 sides, 2 of them would be the exact same length. The third, not the same. Our third type of triangle is a scalene triangle. And a scalene has no equal sides. If you measured those sides, none of them would be the same length. Every single side is different. So let's look at some examples here. So an equilateral triangle. We represent something being equal by these double dashed lines. Kind of always made me think it looks like a kitty cat with whiskers. But an equilateral triangle, all 3 sides are the same length. What is this? This is an equal symbol, right? Yeah. So equal symbol on the sides represents an equilateral triangle because it's on all 3 sides, meaning that if you got out a ruler right now and you measured this side, it would be the same length as this side, and it would be the same length as this side. Equilateral triangle, 3 equal sides. All right, an isosceles triangle we just talked about, it has 2 equal sides. So 2 of the sides are equal. If I measured this side and this side, they would both be the same length. But if I measured this side, it'd be different. So say that we were measuring in inches. If I measured this and it said 2 inches and this said 2 inches, this would not be 2 inches. This would maybe be 2.5 inches or 3 inches. Okay, this third side is not the same. A scalene triangle, none of the sides are the same. So if I measured this, maybe it would say 2 inches, maybe this side would say 2.5 inches, and maybe this side would say 1 inch. All three sides are different lengths. So equilateral triangle, all three sides are exactly the same length. Isosceles triangle, 2 are the same, third is different, and scalene, all three are different. Scalene triangles are pretty crazy looking triangles. You are used to equilateral triangles and isosceles triangles for the most part. Scalene triangles get a little funky looking. All right, so when we are naming our triangles, this is what we're talking about. We're going to be naming our triangle based on the angles, a description of those angles, and a description of those sides.